So let us start the Moscow Telecommunication Seminar. Our today's speaker is Artem Krasilov. He received his Master of Sciences degree and Ph.D. degree in telecommunications from Moscow Institute of Physics and Technology. And currently he's a senior researcher at the Institute for Information Transmission Problems of the Russian Academy of Sciences and at Higher School of Economics. He is also a senior lecturer at MIPT. He's been involved in various national and international research projects supported by both academic foundations and industrial partners, and received several awards from Russian government and industrial partners. His professional interests are related to next-generation wireless networks, 5G, 6G, Wi-Fi, quality of experience, quality of service provisioning in wireless networks, and he has co-authored over 40 research papers. And our today's seminar is titled The ITU Vision on 6G. Artem, the floor is yours.
Thank you, Dmitry, for introduction and inviting me to this seminar. So, as stated in the title, today we will talk about 6G, and I will try you to show what 6G could be according to the recent documents published by the International Telecommunication Union. So my talk will be split into 4 parts. So in the first part, we will shortly consider how the development of cellular technologies, so which are the main players in this game and how we obtain new technologies. Second, we will consider the usage scenarios and current requirements for 6G, which is published in the ITU documents, and also consider what will be the basis for the development of the new technology. And finally, we also discuss some timelines, so what I expected in terms of the date for the development of 6G technology. So let us start from the first topic. So currently, in the development of the cellular systems, there are 2 main organizations, 2 main global organizations. The first one, which is on the left, is the International Telecommunication Union, and more specifically, its sector of radio communication is responsible for radio frequency spectrum regulations, for defining the requirements for various generations of the systems, and for the approved of the technologies, of the developed technologies. Note that ITU do not develop a particular technologies, while the specific technologies are developed by the for the last 30 years. There is mainly only one standard development organization. It is the 3rd generation partnership project, which develops specific radio interface technologies, RITs, and provide their detailed specifications, including their performance evaluation results. So the development of the new generation is as follows. So first of all, ITU creates the requirements and some vision on which scenarios and which use cases should be supported by particular technologies. Also, ITU discusses which particular spectrum and which particular bands are expected to be used by the new technology. After that, the 3GPP develops a particular radio interface technology. Also, it evaluates its performance by using its own simulators or any other measures, and provide this detailed specification to the ITU for approval and validation. If we look into the past, we had 3 cycles of such interactions. So from ITU side, the cellular technology or any type of these RF technologies are called international mobile telecommunication. So this is the special term used by ITU for this set of technologies. And the particular requirements are called according to the year to which these technology will be deployed. So, for example, the 3G technologies were expected by 2000 year, and the corresponding ITU requirements and the corresponding generation of cellular technology was called IMT 2000. And we know that 3GPP have developed the WCDMA technology, which was the technology which met the requirements provided by the ITU. For the fourth and the fifth generation, we also have such documents, and the last cycle just started. So currently, the ITU have published the requirements for IMT 2030. It means that it published the requirements for the sixth generation of cellular systems. And in the next years, we're expecting that there will be developed some technology which will meet such requirements. Okay. So today we will talk about two main documents which were published by ITU, and the documents describe what will be 6G, what will be the usage scenarios, what will be capabilities of such systems. And the first one is called Framework and Overall Objectives. So the idea of these documents is to describe what we expect as the community from the new technology. And the second document, which is also interesting for us, is what the technologies will be used to build such a new communication system. Okay, let us start from the first document and discuss what was envisioned by the ITU as the usage scenarios and requirements for the 6G systems. The development of any technology starts from considering what will be the main usage scenarios, what will be the new applications which will require the new technology. So let us shortly consider what, in terms of new applications, what in terms of new scenarios is expected by the ITU from the 6G. So the first set of scenarios is called immersive communication. And from the current technologies, we already know the application which is called Cloud XR. So this is a type of application in which the user obtains the video and voice with high resolution. What is expected next? So we expect extension of this application in two directions. The first one is the increase of the resolution and the field of view. So it means that we will increase the quality of user experience for the video which is displayed on the headset. And also the new part is the adding of the new functionality such as tactile or haptic communication. So in addition to the voice and video, we also want to transmit the touch, temperature, or if possible, want to transmit a smell. So the example of such an application is the communication with the robot avatar. So suppose you have some dangerous place or maybe some unexplored place and you send the robot to this place. And by sitting at your home, you want to touch and you want to explore the new place without being there. If we looked at some requirements for such kind of applications, so typical numbers for the throughput is around several gigabit per second. And the latency which is needed to provide really immersive communication is below 10 milliseconds and below 1 millisecond for the tactile communication. Another type of immersive communication is holographic communication. So here we have the transmission not to the headset, but we project some 3D video. And there is a lot of applications for such type of application, like entertainment, education, manufacturing. If we look at the typical requirements, the expected throughput generated by such kind of application is also around several gigabit per second, with end-to-end latency below 10 milliseconds. The new technology, the new idea which will appear is in 6G is the concept of digital twins. So what is the digital twin? The digital twin is some copy or a model of an existing physical object. For example, suppose we have a fabric in which we have some robots or some objects, and we want to recreate such a system inside our computer to model it and, for example, to optimize its performance. So what we need to build the digital twin system, so we need to place a numerous number of sensors, so to have some kind of IoT network to gather a lot of data about your real object. Then the server based on this information creates the model of the physical object and determine the set of actions. For example, in case of roads, we want to switch some traffic lights in order to increase the speed of vehicles. And then actions should be sent to the actuators. So, for example, for the traffic lights, to build the digital twins for really big objects like cities, we need numerous number, so up to 1 trillion of sensors and actuators. So we have much more devices than we expected in the 5G. Since we have so many devices, it's almost impossible to replace batteries or even put the batteries inside them, and it's expected that such a system should provide almost zero energy consumption, and, for example, consume the energy from the ambient. And also, if we want to provide the real-time control, we also need to provide a very low latency. So, for example, at the factories, to provide some communication to robots, we need very low latency, up to 1 millisecond. Another new idea which will be considered in 6G systems is to also enable sensing in our communication systems. So how we typically use the RF spectrum in our communication systems. We generate some signals and receive them at the other side in order to transmit some data. However, we also can use these signals in order to do some other things connected with sensing. So what can we do? First of all, we can localize some object with very high accuracy. Second, we can create ultra high definition images similar to the cameras, which create some 3D understanding of the environment. We can use the signals, for example, in millimeter wave and terahertz frequencies in order to create such ultra high definition RF images. Another use case is also the measuring the pollution and, for example, detecting the sources of this pollution. All of this is called integrated sensing communications, in the sense that we want to use our usual communication systems and provide additional sensing service with almost no influence on the performance. So the second requirement, which is listed here, is the providing the almost no influence on the communication performance. Also, since the creating the 3D maps will provide high energy consumption in terms of the energy consumed by the base station, also one of the main requirements is to reduce such energy put into this feature. Another important and the new thing which will be the key enabling technology for 6G is the usage of the artificial intelligence. And we will see a very high integration between the artificial intelligence and communication. So in order to build some AI model, we need to gather some data, send it to the server, create the model, and then make a decision on that. So this is the network part of the job. While the AI algorithms can be used to improve the network performance. So we will see that from one side, the network will provide the resources for transmission of training data and also the resources for computation of AI models. On the other side, AI will provide some solutions, provide some recommendations on how to configure the network in order to improve its performance. From the requirements, we need to provide the end-to-end latency below 10 milliseconds, which is needed for in case of if we need the real-time control. And also, again, since we have a lot of computations, our goal is to provide low energy consumption of the system. The last important point for the 6G is the providing of the coverage. So even with 5G systems, there is below 60% coverage of the Earth. So the main target, which is set behind the 6G, is to provide almost the coverage and broadband access almost everywhere. So how it is expected to achieve? First of all, by deploying more stationary and mobile bases, so the terrestrial part of the network, and also the new thing which has appeared in 5G just recently is the usage of non-terrestrial networks, and in particular by setting base stations at the satellites and high altitude platforms. So merging all together, if you remember the picture for the 5G, it is a triangle with three vertices, one corresponding to MBB, the second one to MTC, and the Ural-C. For 6G, the picture is a hexagon with 6 vertices. 3 of them are considered as extension of the 5G usage scenarios, while the other 3 vertices, which is marked on this picture by the blue color, is a new usage scenarios. For the green part, you see that the eMBB is converted to the immersive communication. And the difference is that we not only require high bandwidth, we also need low latency, which is required for immersive XR and, for example, for holographic communication. MTC is extended to massive communication with a much higher number of devices and almost zero power consumption, which is needed, for example, for digital twin applications. Ural-C is transferred to the hyper-reliable and low-latency communications. And the difference is much more stringent requirements on the reliability and latency, for example, which is needed for the tactile communication. For the new usage scenarios, it is the integrated sensing and communication. As we discussed previously, we want to use our communication network to to obtain some information about surrounding objects. Integration of AI and communication, so usage of AI for communication and vice versa. And the last one is providing the ubiquitous connectivity. So the network provides almost full coverage of the Earth, and also it expected that the coverage will be provided to the air object like airplanes, high altitude platforms, drones, and etc. Also, the ITU have formulated some specific technical requirements, some specific figures which should be provided in order to meet the requirements of the mentioned previously usage scenarios. So one of the main requirements in the data rate, so the data rate for the 5G system was 20 gigabit per second as the peak data rate. While for 6G, it is expected that it will be from 50 to 200 gigabit per second. So the gain will be from around 2 to 10x with respect to the previous generation. Also, importantly, that in contrast to the 5G requirements, the 6G requirements is provided as a range, not as a specific value, but as a range of values. And which particular number should be provided will mainly depends on the scenario and mainly depends on the use case. In terms of the connection density, so we see around 2 orders of the magnitude increase in the number of devices per square kilometer. Mobility with respect to 5G will be increased to 1,000 kilometers, and it's mainly related to the air object like airplanes. Latency for some of the industrial applications and for some tactile application will require up to 0.1 millisecond, which is 1 order below of the 5G requirement. And reliability also for some scenarios require up to 1 minus 10 to the power of minus 7. The new technical requirements which appeared in the ITU document is the positioning accuracy. And the position accuracy is expected to be around several centimeters. Let us now discuss how we can achieve such a goal. So how can we achieve such high spectral efficiencies, latencies, etc.? What will be the technologies which rely on the 6G? So the first and the main asset for any wireless communication system is the available frequencies, so the spectrum. And for the 6G systems, we expect the following. We expect that 6G can use the already available spectrum for 5G, plus some new bands. And since the frequencies below several gigahertz are already occupied by the communication systems, so the only way is to go upper and upper, and it's expected that the 6G will use sub-terahertz and terahertz bands. So the terahertz bands is the bands from 100 gigahertz up to 3 terahertz. So what is good for these bands is that there is a large amount of spectrum, so we can have the channels of the bandwidth up to several hundreds of gigahertz, and in theory it can provide us with up to 1 terabit per second speed. However, it is not as good for now as in theory, because there is a lot of issues in implementing this technology in practice. So the first main issue with terahertz communication is the design of the transceiver. And the problem here is as follows: since we have very high bandwidth, so since we have hundreds of gigahertz of spectrum, we need to provide very very wide signals, and we need to have a lot of processing to process such a signal and to process terabit per second data. So the important part is how to build such a transceiver which provides low complexity and low power consumption. Another issue for terahertz band is very low coverage. So only a few meters currently can be provided even with narrow beams. But there is some measures, and I will talk a little bit later how we can increase the coverage in terahertz and in millimeter wave bands. The second important part for the spectrum is how we use it, and of course the efficient spectrum utilization is an important part for 6G also. The first point is the need for advanced carrier aggregation. So currently the 5G and 4G uses carrier aggregation, but it do it inside some particular band. So for example, inside 3 gigahertz bands or inside 5 gigahertz bands, but not between the different bands. And it expected that the carrier aggregation functionality will be extended also to support the aggregation of low, medium, and high frequencies. So, for example, 2 gigahertz, 20 gigahertz, and 200 gigahertz frequency. Also, in low frequency bands, there is a high fragmentation of the spectrum. So we have a lot of low bandwidth channels, like one megahertz below the 1 gigahertz, but we have a lot of them, and the idea is to use many such small bands in order to provide broadband communication. But here we need to have again good transceivers to operate in this fragmented spectrum. Also important part for the spectrum utilization is to provide efficient usage of the spectrum by different operators and radio access technologies. And the idea is here to use, for example, AI algorithms in order to coordinate the usage of the spectrum even between technologies of different generations. Let us go next. The next important thing for the 6G is determining which will be the waveform which will be used. And there is an understanding that the classical OFDM waveform which was used in previous generations is not enough for the terahertz and sub-terahertz bands, and there will be need for the design of the new waveform which provides low power efficiency, so provides a low bit per joule energy. Also, since the 6G is going to use high spectrum, so to use millimeter wave, sub-terahertz, and terahertz, there is a need for new modulation schemes which allows to suppress the phase noise and provides low peak to average power ratios at these high frequencies. From the codes, there is the following requirements. So first of all, there will be a much wider range of the code rates and the code lengths. So, for example, in order to provide 10 to the power of -7 packet loss ratio, we need to have the code rates much lower than that in the 5G systems. Also, since the energy efficiency and latency is important, the codes also should take into account such constraints. And currently, the candidates which is considered to solve this problem is the advanced extensions of the LDPC and the polar codes. The third very important part from the physical layer solution is the usage of advanced antenna techniques. As you might remember, the 5G is the first technology which used massive MIMO, so used a lot of antennas in order to increase both the coverage and spectral efficiency. And it expected that this direction will be continued in 6G. And the usage of thousands of antennas in millimeter wave and terahertz bands is also called an ultramassive MIMO or extreme MIMO, and it will be used in order to create very narrow so-called pencil sharp beams in order to increase the coverage, for example, in terahertz band. Also, an important technology for improving the spectral efficiency is the usage of the concept of self-free MIMO. The idea here is as follows, that we will use the antennas of different base stations in order to serve a particular user. So by doing this, we virtually increase the number of serving antennas, and thus we can increase its spectral efficiency and the SNR. A new direction for the antenna technologies, which appeared quite recently, is the reconfigurable intelligent surfaces. So this is the large array of passive elements. So this antenna array is typically a passive antenna, which do not emit its energy in the band, but this surface reflect the signals and direct it, for example, focus it for a particular point. Some intermediate solution, it could be considered like intermediate solution between the extreme MIMO and RAS is the holographic MIMO. So the idea here is that we have a lot of physical antennas, like again, thousands or 10,000, but we use a low number of RF chains because the increase in the number of RF chains, of course, increases the power consumption and the complexity of the device. And the idea is how to design such algorithms for such a system. Now let us turn to the medium access control layer. So how the different users use the common spectrum. From the multiple access point of view, for 6G, it expected that there will be both the orthogonal multiple access and non-orthogonal multiple access. The orthogonal multiple access still will be needed to provide the guaranteed course. So if we need to provide for the user some specific throughput, some specific guarantees in the latency, the best way is to allocate a separate resource either in time, frequency, and code domains for the particular user. However, for the scenarios, for example, of the digital twins or scenarios with high number of users, the number of devices will be so high that we don't have an opportunity to provide a unique resource for each user. And in particular, it is important when the users generate sporadic traffic. In this case, the non-orthogonal multiple access schemes will be important. And there is a lot of ways how we can organize transmission of the data in the same time frequency resource. And the three ways are listed on this slide. So first of all, we can separate the signals of different users in the space domain, in power domain, code domain, and also recently there are proposed various schemes which combine some of these three schemes. And the question, open research question, is which particular scheme will be used in the 6G standards. In terms of resource allocation, there will be still used two approaches. The ground-based, the approach scheduled by the base station. So it is used again to provide the guaranteed quality of service for the user. While for some scenarios with, for example, low latency and for the sporadic traffic, we can use and we need to use the grant-free access when the users randomly select the resources from the set of previously configured ones. And since the number of users will be much higher in the 6G systems with respect to 5G systems, important problems for research is the new low complexity multi-user detection and decoding algorithms should be developed. The third novelty at the MAC layer is the enabling of the full duplex communication. In the recent release of 5G, release 18, there was introduced some kind of full subband full duplex, meaning that the base station can transmit and receive data in the same time slot, but in different frequency bands. So these two frequency bands do not overlap in the frequency domain. While for 6G, it expected that there will be so-called true full duplex, meaning that the base station can transmit and receive data in the same frequency, so exactly in the same at the same frequency. However, still such a technology is not mature because there is a need for robust self-interference cancellation algorithms. The third important technology, which we discussed previously, is the usage of artificial intelligence. And it is expected that the AI algorithms will be used inside almost all layers of the protocol stack, so from the physical layer up to the network layer. The first part of the technology is related to the usage of AI for the control and even design of the radio interface. So how the data is transmitted from different users. And here there is a lot of optimization problems which can be solved by using usual optimization techniques, while in 6G, it expected that such an optimization problems will be solved by the artificial intelligence algorithms. Also, from the network side, from the control and optimization of the radio access network, when we have a lot of base stations which interfere with each other, which should serve different users. Also, there is a lot of parts where we can use AI in order to improve the wireless network performance. Let us now talk about when we will expect the appearance of the 6G. So on this slide, you can see the figure from the ITU documents. So currently we at the 2024. So the ITU have finished so-called framework. So the framework is the set of documents in which the ITU have described the key usage scenarios and application. So that was discussed by us in the second part of our talk. Then the ITU will work on specific requirements, on the design of specific scenarios and target KPIs, which will be used in order to evaluate the developed systems. Then the standards development is the part which will be done by 3GPP. And then based on these technologies, there will be some system deployment. Okay, this is from the side of ITU. Let us look what is the plan of 3GPP on 6G. So now the 3GPP have finished the release 18. So this is the release of corresponding to 5G. And also it is known as 5G Advanced. So this is like a new version of 5G technology. And it is expected that 5G technology will be extended in the next releases of 3GPP. While starting from release 19, there will be some work on the development of the 6G technology. So the release 19, so the current release 16, is expected to be used for the design of scenarios and target KPIs. This work includes the determining specific scenarios which will be used for further performance evaluation. So previously, as we discussed, ITU provided some general figures. For example, we require around 200 gigabit per second. But we need to specifically determine in which particular scenario, with which particular traffic, with which particular parameters we need to achieve this 200 gigabit per second speed. So this will be the work of 3GPP to determine in such scenarios and target KPIs. Of course, based on the ITU documents. Then the important part will be in release 20. So release 20 is expected to be the so-called 6G study item. So the 6G will consider different technologies. So for example, the technologies we have considered in the third part of my talk. And the 3GPP will compare them in different scenarios, compare their performance, and determining what technology will be used and which technology will not be used in specific technology. Then in release 21, it is expected that there will be the start of the standardization work. So the 3GPP will provide some specifications of the 6G, and then evolution as in 5G for the 6G will start in release 22. So some concluding remarks. So currently in 2024, ITU has already provided the basis for 6G research and development. So having these two documents, we know which will be the typical requirements, which will be the usage scenarios, and what is expected to be the technologies to be used for the development of 6G. From the 3GPP side, we see that there is only a start of the work on the 6G, and the specification work will be exactly start at around 2027. So from us, as researchers, I think it's right time to start the research on 6G. And at the end, I want to wish you success on this road, and I will be glad to answer your questions. Thank you.
Thank you, Artem, for your interesting presentation. So let us start with the questions. And the first question is by Vladimir. Can you explain more what is the difference between digital twin of an object and physical mathematical model of that?
Okay, so actually the the terminology is as follows. So for my understanding, the digital twin is the concept of translating the physical world to the virtual world. So we have some real physical object like roads, fabric, as I mentioned, and we want to create in our virtual worlds, we want to create some copy, some model of this object. And to do that, we need to train our model, so to feed our model with some data. And this data is gathered from our real objects by gathering the data from the sensors. So the answer is the digital twin is the concept, while the digital twin includes both physical object and the model, the model inside the virtual object, and they communicate with each other.
Artem, what is the reason to create such digital twin? If we already have object, we can use this object with sensor data for like data processing. Why do we need to create such object in the virtual world? Maybe digital twin still a little bit different application area, not just virtual world copy.
So when we have the copy of the object, we have the model, we can not only just look at this model, we can look at it as the mathematical object, for example, to do some optimization of this object. So we do optimization inside the virtual world, make some decision, and then translate this decision to the physical world in order to make physical world better, to work better.
Okay, there exists another concept called like hardware in the loop modeling, when you include hardware part, physical object, to the mathematical model, and you try to compute or optimize system mathematically when physical object already embedded in this mathematical simulation platform. Is it the same story with different name?
Maybe because I'm not exactly familiar with the term you mentioned, but so the idea is that you use the model to optimize something and then to apply your solution on the model on your real object. That's the idea. Maybe there is some intersection between terms, between previous terms already exist in some literature.
Okay.
So ITU prefers to use such a term.
No, I try to understand the difference because many people use this one and sometimes seems not everyone fully understand what it is.
Okay. Maybe it's just rebranding or something exists.
No, yes, so I collect just different opinions on this term. Another question about frequency range, which considered as targeted from ITU side. You more mentioned about millimeter waves and terahertz frequencies.
Yeah, the terahertz frequency is also an important direction for spectrum.
Do you think, or in your personal opinion, or maybe some ITU-based information, that this is the most interesting ranges for 6G communication systems?
It's difficult to give some, let us say, accurate answer. So first of all, it is expected that the 6G will reuse already available spectrum. So they will use the bands below 6 gigahertz. They will use millimeter wave, and of course, it's expected they will make in millimeter wave technology more mature. But the sub-terahertz and terahertz bands, I think this is like a new thing that the 3GPP will try to touch, but when they will success, nobody knows.
Because vendors on Barcelona exhibition almost discuss centimeter waves, like 10, 12 gigahertz, and with high probability for transition period 6 to 7 gigahertz frequencies, even below than 28 gigahertz.
Yeah, you're right. So it depends on which sub-frequencies will be released from other technologies. So we have current assignment of the frequencies to different radio technologies by ITU. And of course, if some frequency bands in the low bands released, of course, it's the interest for the cellular systems, for the 3GPP, in order to utilize it. So because we understand that higher we go to the frequency, the lower we have the coverage, and we have much more problems with the transceiver design.
There exists opinion that terahertz only for chip-to-chip wireless communication. It's not for even device-to-device. No, just for information. And last question, maybe about ISAC technology, integrated sensing and communication. You also mentioned there is mostly about ultra high definition story, about terahertz or sub-terahertz region. Yeah, do you also think that for ISAC technology it's still these frequencies? I believe it should be about 10 gigahertz, not far, because you assume to sense environment, but also you mentioned that terahertz is just maybe
few meters.
About 1 meter, yeah?
Yeah.
So it is almost nothing about environment around 1
actually, meter. Yeah, the main bet will be on the millimeter wave. So because it's like a good trade-off between the it provides high enough resolution with low requirements on the energy. So to reach some distance at the terahertz band, we need much more power than at the millimeter wave. So yes, my expectation is that here the millimeter wave will be one of the mostly used bands for such a task. But for positioning, maybe still other usual frequencies in below 10 gigahertz. So
yeah, but there is
for localization purposes.
Problem to achieve centimeter level accuracy.
Yeah, but this is just their
challenge
wish.
Goal. Let's say.
If possible, let's see.
Okay, and I have just one comment. Today or yesterday there was created new consortium on Barcelona exhibition about AI called AI-RAN, AI Radio Access Network. Actually, this might be first part of your AI utilization in wireless, where AI planning to be used as instrument for PHY and protocol level optimization. But from 6G concept point of view, maybe AI considered like one of the user type, because there is story to create protocol and network which help to communicate different AI machines to each other. It's not used for network configuration, for physical layer configuration, optimization, but it is like network for artificial and intelligent communications. And then it is a different story about protocol design for such type of links. Just maybe it is some extension of AI application in your materials.
Okay, thank you for comment.
Thank you. No other.
Okay. Let's move on to the next question by Maxim.
Yes, hello. Thank you for the interesting talk. I have the question on slide 6. Yes, you said that firstly, usage scenarios of telecommunication systems are developed, and then technologies for them. But here, looking at the dates, it's a vice versa situation, kind of. So, can you clarify why here the second document was approved earlier than the first one?
So you see, this is first of all, this is ITU documents as recommendations. So if the ITU have described some technology in the second document, it does not mean that the 6G will definitely use it inside specifications of 6G. So actually, the timing for these documents was as follows. So they have started approximately at the same time. So they have started at around 2021. In parallel, people were discussed the first document and the second document. And the story was ended that the second document just was released earlier than the first one, because the first one is like very important document for communication between ITU and 3GPP, while the second one is just some overview of technologies, and it does not require 3GPP to use something that is written in 2, but 3GPP should definitely follow what is written in 1. That's why for 1 there was much more time. There was allocated much more time for the development of these documents. That was that is my understanding of how that was happening.
Okay, I see. Thank you. And one more question, just overall about terahertz bands. So at this range, even the smallest obstacles may completely interrupt the signal. So what are the solutions for increasing reliability of data transmission? Yeah.
Mm-hmm. Yeah, thank you for your question. So for the case of terahertz, when you have completely blocked transmission, you can use. Okay, I'm just looking where to find. Okay, so the solution is as follows. So the device will not use only the high frequency band. It will use also other bands like medium millimeter wave, for example, or low frequency bands. And the data is redirected from one band to another band. So as it's already used in 5G, for example, between to switch traffic between low frequency band and millimeter wave bands. There will be 3 bands, so you can switch between 3 bands.
All right, it's clear. Thank you.
Okay, thank you. And the next question is by Anton Karamashov.
Yeah, hello, Artem. thanks for the presentation, first of all. And can we go back to the slide with the requirements, the numbers, I mean?
Yeah, you mean this one?
Yeah. I'm okay with the most of it, yet I have some doubts related to mobility requirements, even for 5G. It is hard to me to imagine the scenarios with these requirements. You have mentioned something with airplanes. Does it somehow not connected with non-terrestrial communications, or what is the case?
Okay, so about 5G and 500 kilometer per hour, the typical use case with such a speed is the high-speed trains in the Europe, in the Japan. So they reach they can reach such a high speed. As for the 6G and 1000, so this is again a typical number corresponding to the airplane, and it is expected that mostly the airplanes will be served by non-terrestrial network like satellites. You're right.
Okay, seems interesting. And probably when you have presented some ideas related to new modulations, the majority of the listed in the slide are modifications of them. So can we achieve such speed and performance, and let's say with ODM-based modulation schemes? I assume we need something else like pulse modulations to receive the signal with such a high speed. Yeah. Could you comment on that?
You mean the waveforms for the the millimeter of terahertz? So this is.
I probably don't mean the terahertz even. Let me clarify. I assume that if we use OFDM waveform and OFDM-based code schemes, we may experience some, let's say, Doppler effects, and we will unface some serious problems with a reception of the signal at such high speeds. So can we overcome this factor?
The Doppler effect for such high speeds exists, and usually this problem is solved by using the pilots, and in particular demodulation reference signals. So there is a different schemes how you can place pilots on the time frequency grid. So you can do it much denser if you move with high speeds. And these pilots is used to post-compensate the Doppler at the receiver. So actually FDM works with problems. Yep, you have problems. You do have problems in OFDM with the high speed. But the pilots is the way to compensate Doppler.
Okay, thanks. And maybe as last one, do you know about some real-world experimental results in this domain? I mean, for new radio, of course.
You mean new radio high speeds?
Yeah.
Is
it possible to achieve in a real world? Let's say.
I need to look more into the 3GPP specs, but what I remember now in this particular topic, the 3GPP has specifically has specifically added some work in specific bands in around 700 megahertz with 3.8 megahertz bandwidth to serve high-speed trains. So maybe if you look into the literature on this particular topic, and I will provide you offline some more specific terms and where it is in the 3GPP, but I definitely know that 3GPP has some study item on the applying new radio for high-speed trains. Yes. So, and hopefully there is a vendor which implements what is written in the specifications.
Okay, thanks. We will see.
Okay, thank you. And the next question is from Ilya Levitsky.
Artem, thank you very much for your presentation. So my first question is related to the list of the enabling technologies, especially in multiple access. So you said that NOMA can be perceived as one of the candidates. Is this list presented by you, or did you find it as something that ITU said?
This is this is the list of possible NOMA schemes. So we know that NOMA can be implemented in different ways, and this list is the exact list which is mentioned in the corresponding ITU document as a candidate scheme for implementing NOMA.
Okay, so correct me if I'm wrong, but 5G already has some NOMA-related parts, right?
Yeah. So you for 5G, the power domain NOMA is can be implemented on top of the standard. So the standard does not forbid to implement power domain NOMA.
Mm-hmm.
Yeah, so maybe in 5G, in 6G, there will be used some specific techniques like SCMA, MUSA, or something else, specifically put into the standard. And the key idea for NOMA, the key usage scenario for NOMA for 6G is expected not in increasing the throughput for high bandwidth traffic, but it is the methods used to serve many users with sporadic traffic. So mainly to the IoT scenarios when you don't know which particular users when they will transmit. But if you will try to allocate a separate resource to each user, you will see that you don't have enough resources for that. And you definitely need to multiplex users with some scheme. Which one to use, ITU do not specify.
Okay, I see. Thank you for that. My second question was related to the cooperation of 6G technologies with some other ones. Is that something new, or did 5G tell something similar?
You mean about flexible spectrum usage, or?
Well, yeah, you mentioned that 5G technologies can cooperate with other technologies. I assume that there's some kind of cooperation in the same spectrum.
Yeah.
So does 5G already say something like that?
The 5G has some mechanisms to cooperate with LTE, with the previous generation. Mm-hmm. And it was needed to migrate from the LTE to 5G in some frequencies. So, for example, two neighboring base stations, one of them is still 5G, is still LTE, another one is 5G. They need to cooperate somehow in the frequency bands. So yes, there is some cooperation in such a case.
Yeah, well, this sounds like a sort of backward compatibility, which is kind of obvious, but do ITU mean anything related to, for example, Wi-Fi cooperation or, I don't know, LoRa cooperation, something like that?
The cellular technologies typically use license band, right?
Yeah.
So in license bands, you need to cooperate with technologies which work in license band. I cannot imagine other technologies which, other than cellular, which work in the license band, right? So you don't need to cooperate with Wi-Fi inside the license band because Wi-Fi do not work in license band.
Okay, I see. Yeah. Okay. That's it for now. Thank you very much.
Thank you.
Okay, thanks everyone. So I think let me ask the last question here. So Artem, can you make some kind of a forecast? Which of the scenarios that you listed during your talk will be implemented the first? Like
Okay.
some of the scenarios require some more ambitious possibilities, some are less ambitious, so which are more realistic that we will achieve in the next several years.
Okay, so I think the first one is the best one. Yeah, but I think since the cloud XR is already something existing for 5G, so we have already some way gone to this technology. Maybe this is the best candidate for extension, and this is the best candidate to appear with the new possibilities. For example, making higher resolution and high field of view is not a very big deal. Yeah, but the second part will require some new technologies, new sensors, new capabilities. But I think the extension of Cloud XR is the one which will be the most closest to in the future.
Okay, thank you. So we'll see if the forecast is real. Yeah, and okay, thanks everyone. Thank you, Artem, for your very interesting talk, and let us conclude the seminar. I wish everyone a good evening, day, and let's meet again for another seminar.
Thank you very much for interesting discussion.
Goodbye.